All right, this is a bad idea. It's always a horrible idea to do this. We are live. Good afternoon. Well, technically still morning for me. It's 11:40 right now. Boy, what to talk about? Let's see. On Praise's stream the other day, there's been a little bit of interesting progressions in the community. There's been some interesting smoke being thrown up, and Smokey is going to start a piss fight with Praise and other people. Evidently, this is the fate of our community, and this is the fate of Smokey to continue these perpetual cycles of arguments and being vitriolic and judgmental. Let's see, what else is new? Last night, Knock went live. I was in there. We started viewing Otangello's. Well, not Otangello's, but Smokey's conversation with Otangelo. That was kind of interesting. It's a good review, not overly long, with about an hour and a half, hour 30, hour 45 minutes or so. That was pretty fun. I had a talk with Otangello yesterday on abiogenesis, and more so it's been a conversation about, more so it ended up being a conversation about kind of starting points and differences that we hold within our worldview. So that was kind of interesting. And somebody else is joining. Who is this imposter?
It's an imposter. Can you hear me?
Yep, I can.
I'm not going to be around very long.
Uh-oh.
Consider me the drunken peasant who just stumbled in the door.
Well, there we are.
Who the fuck are you people?
Who are you?
Who are you? That's the better question, isn't it?
What am I named? Oh, I'm named Speed of Sound. Do you remember? I used to run this fucking jack.
Oh yeah, that's right. Until you,
I used to own this bitch.
Yeah, you used to own this bitch until you gave up the license temporarily to me and Walker and whoever else.
The official story is you guys stole it from me.
That's the official story.
Yeah, I'm going with that shit.
That's the word around the block. The production value is increased. 1 second.
I fucking hate that. Will you guys stop doing that? What the fuck? I turned my back for 1 fucking minute and you got banners and countdown and music. I mean, that's what we're all about here, you know? What the hell are you doing to me? Anyway, how are you? How are y'all?
Well, we all good. How about you?
I'm trying to get my head back into biology a little bit, and it keeps bouncing off. But I'm going to give it a try. I listened to a little bit of the Otangello thing, and I'm going to bail here after. I'm not coherent. I don't know if life kind of sucks right now.
I know, right?
Yeah, but you know, life sucks, but it feels good. Life is good overall. Life is fucking wonderful. So embrace. We're all still alive.
True.
So Otangello, I was trying to do some thinking about what Otangello was saying, and these guys have a remarkable relationship with the idea of evidence, and it changes depending on whether or not they're asking us to explain something or whether they're explaining something. And like Otangello yesterday, you asked him, what the hell did you ask him? Something about the beginning of God or something. He's like, oh no, we don't have to explain our beginning because it's God, but you have to explain your beginning. And I'm like, that's kind of a double standard, you know, for we have to explain the beginnings of life, but he doesn't have to explain the beginnings of God.
Because you have to believe.
What's that?
You have to believe. There's no evidence. You don't need evidence when it comes to just believing or just applying faith to your belief. You just accept it for what it is.
Yeah, and they have something that's called it's kind of a complicated enthymeme, which is when you embed something in your premises that's not it's not spelled out specifically, but it is assumed to be in there somewhere, and and you embed it in the premise, and it ends up being the conclusion, and it's circular, begging the question. So, and they believe thoroughly in the Bible and in God coming in, so they think they have answered all the questions, and you can't, and then they demand that you answer the questions with science.
Yep.
But to answer the questions with science would take a set of books that would stack to the moon or to Mars and back 5 times. But they don't have to do that. They have a smaller book, with a very abbreviated story.
An easier book to just believe in.
Yeah.
Speed, you know who Mr. Batman is?
Yeah, I do.
Unfortunately, I do. He's a psychopath.
I heard him debate whether the flood actually happened.
Yeah.
And his response to each and every question about, well, explain the methane, explain how all the species got the ark. His answer was, God provides. God provides. In other words, he can answer magic to any question you raise. And if you want to say something, no, you have to actually prove it.
Okay, so chemistry provides. So every time they ask us, how did this happen? Chemistry provides. Chemistry,
Yep.
Chemistry is, and you did a little bit of that yesterday with Otangello, and I think it went right over his head.
I wasn't about to get into organic chemistry, like hardcore orgo with him.
Yeah, but you basically, you in a way explained the presupposition that the natural laws exist, the physical universe exists. We don't have to explain how it got there. They feel that we do. I don't think that's fair, because
the thing is, like, when you take a naturalistic or materialistic position, that has to be your starting point. Yeah. Because that means if you do something else, right, it means that there has to be something more fundamental which grounds the natural. As being a proper starting point, which that's hard to do.
That has never been how naturalism or science works. Naturalism and science starts where we are now, and we calculate how the world works around us locally, in the present. And then anything else is basically cream, cream on the cookie. Anything we can figure out about the past, but we figure out how science works today. And we assume, we just assume that natural laws work, chemistry works, the physical world is here, I can grab my coffee.
Well,
we do not have to provide all the answers all the way back to the beginning.
Well, the thing is, I don't think it's possible to provide one without invoking natural terms first. So how exactly are you to refer to a system which grounds the natural without referring to it implicitly in some type of space or within some type of time frame?
Yeah.
Right. Describing some type of space where an event occurs, and in what time does that event occur? Like being now, in the past, in the future. Those are all terms which are naturalistic at their core.
Yeah, we have a 4D model of space-time, and we understand a great deal about it, and we know that it is embedded in something much more complicated. And for them, they just say God. Well, we can just say the greater universe, or what the hell do they call it? I wouldn't want to call it a multiverse, but the universe, basically. Yeah. So our local universe is embedded in a greater system, which we don't understand any more than they understand.
Cosmos.
God.
Yeah,
right,
the entirety of the cosmos.
There you go. Cosmos. So we have to, and they've always got us defending our position,
Yep.
And they don't want to defend their position at all. They're just, God does not have to have a beginning.
And the thing is, he's
I just want to address something Speed said. I think it was Carl Sagan, I'm not sure, who gave a recipe for apple pie. The first ingredient is a universe. And I think that captures what you just said. It's like, of course I can give you a recipe for an apple pie. First, you need a universe.
Right. Oh, that's pretty cool. I'd love to see that quote. I've never heard that one.
I think it's Carl Sagan. I'm not sure. I'll try and look it up. Yeah, go on, Immutable. I'm sorry.
Yeah, no problem. It's the other thing I noticed like that was cute was when I asked him about like how does this God, so like he claims God is a supernatural thing, exists outside space-time. Fine, I can buy that for the sake of argument. But how does that thing interact with the physical world? Like how does it create anything if it's essentially disembodied? Right? How does it create and direct things in the physical world when it doesn't have a physical or material substrate by which to do it? Right? How does that work?
He said something like
that
it's
be like a 2D, 3D conversation then? Like 2D can interact with 3D, but 3D can interact with 2D?
Yeah. Well,
he made some comment about that, and he said, well, God is just timeless, and he can just do anything.
Yeah, but he also said God is immaterial, right?
Yeah, but he can do anything. Oh, he said that God can imagine anything. I think that's how he put it. God can imagine anything, and it just happens.
Well, so can I.
I can too. Yeah, we all can. So SpongeBob imagination is apparently the explanation for God.
Well, I can, but there's a difference between something being potential and actual.
Yeah.
So you might like the answer that Jewish esoteric teachings give, which is that God filled everything that there was, and then God simply sort of moved out and left an empty space. And within that empty space, the universe formed itself.
Wouldn't
as
that be
soon
kind
as
of like
God
pantheism?
Sort of vacated it.
Wouldn't that be kind of like pantheism, though?
That's Jewish esoteric teaching, so it's a bit hard to explain.
Like
but the idea was that God was everything, everywhere, and then he simply moved out and left an empty space. And there was no such thing as an empty space before that. And it immediately filled with the universe. So it's an interesting thing.
That's kind of curious.
Yeah, the Jewish explanations.
But so it means that God was material at some point and became immaterial.
Well, that's an interesting question. It's not exactly clear.
Yeah, that's kind of even more puzzling because it means like there's a transition between him being part of like that fabric of space-time and then not at some other point in time.
Mm-hmm. And then it brings up interesting questions when you consider that we think that a vacuum immediately creates a universe.
Yep.
So somehow maybe they like stumbled onto something. Who knows?
Could be.
Yeah, but it's a cool metaphor.
It is. Yeah, it's interesting to see the types of explanations that Otangello will give in terms of God.
But
because they're kind of amusing.
Otangello can't even explain if entropy was around before the fall. He can't explain anything.
Yeah, that's true. Well, he didn't understand.
Your explanation has a problem. That's all he can say.
Well, I mean, Leo can attest to this. Hopefully he joins. He didn't even understand what a quantum vacuum was and that it's the result of, like, it's a statistical state. And there's nothing which causes it.
Okay, you've gone beyond me now. So either explain or move on.
Typically, a quantum vacuum state is it's a state where particles are allowed to interact and occupy that space. And statistically and thermodynamically, what's supposed to happen is
some of them will leave it. Yeah, I get it.
Yeah. So those particles are supposed to occupy the lowest possible energy states that are allowed. And the lowest of all possible states that can be obtained is is what's called 0-point energy of a quantum field. Yeah, that's true. Otangello didn't know what a vector was, so that's kind of amusing.
Basically, if I understand correctly, statistically, there's a chance that right now a vacuum will be formed in the room you're sitting in, and you'll be sucked in and die.
It could.
Statistically, that can happen any moment.
Mm-hmm.
That's what you mean by a quantum vacuum, if I understand correctly.
Don't you need space-time for quantum foam? I'm not necessarily sure. I think space-time is considered more of a metric space. Like it's a space to quantify like the allowable positions for quantum particles to occupy. I'm not sure if it's something that's necessarily embedded within space-time. It's kind of like, so chemists use the example of kind of like vacant houses or roommates, for instance. There's a limit to how many particles can occupy one energy state before that state is filled and can begin to occupy another. And there's certain rules in quantum mechanics that that occupy it. Well, that define how many particles per state can be allowed. Why doesn't Leo get his ass in here? Explain freaking physics. I'm not a physicist.
Neither is Leo, but he's good at it, bastard.
Yeah. Damn fucking mathematicians.
Nah. So moving back to Otangello.
Mm-hmm.
Anything else he said?
I'm trying to think. He thought that the laws of nature were prescriptive, not descriptive.
Please! They all think that.
Yeah, that was a fun conversation. Let's see. Quantum foam is space-time fluctuations. Space-time exists.
Yeah, all laws require a lawmaker. Right?
What do you say?
All laws require a lawmaker.
Yeah. That's jungle jargon's famous scallop.
That's not true. That's true of human laws. That's not true of anything else. It's like laws of nature are simply mathematical descriptions of natural phenomena. We see a pattern, we describe it, we call it a law of nature.
Yep.
The last time anyone thought that these were prescriptive was like Newton or something, and he was wrong, obviously.
To be fair to Newton, though, I mean, he developed a new field of mathematics almost single-fucking-handedly.
Yeah. But I think Leibniz developed it at the exact same time, if I remember correctly. They both came up with calculus more or less at the same time.
Yeah, that is true. That's kind of interesting.
Probably shows you that like the world was ready for calculus or something like that.
Yeah, I can just imagine like how bored somebody has to be before. Well, I mean, it was the bubonic plague, so. But how bored somebody has to be in order to think, yeah, you know what? I'm going to develop an entirely new field of mathematics.
But he needed to answer a question that he couldn't answer otherwise. Acceleration. You cannot. He needed to figure out how things accelerate. That cannot be done without calculus.
Yeah, he needed a mathematical language that could describe the idea of change, which is embedded in the idea of derivatives and integrals.
Yeah, we all, I suppose that Americans do it in school as well. We in Hebrew we call these road problems. Like a bus leaves the station at a certain time, drives a certain distance. What speed did the bus go?
Right.
But then what you're talking about is the average speed. Newton wanted to say, wait a minute, when it starts moving out of the station, it starts at 0 and goes up to a certain speed. And that he couldn't calculate with the simple distance times whatever,
Yeah.
speed times
Distance is velocity times time.
yeah, exactly. Thank you. That one. VTD, whatever.
Yeah.
I'm not good at math.
Well, and he also can calculate something like, for instance, which is kind of a weird notion mathematically, but what is the speed of the particle at some moment of time, like at that instant? Which is something that averages can't give you, because if you take something at an instant, it technically means that there's no time that's passed. So it should be infinite, but it's not usually.
So I think a very easy way to explain it is you have a car accident.
Yeah.
And the police needs to know at the moment you ran into the wall, what speed were you actually going? Were you going above the speed limit?
Right.
Knowing your average speed is not going to help the police solve that question. So they need calculus to figure out your speed at that exact moment. A graph a curve can only show you what happens over time, not at any specific instance.
Yeah, and the beauty, like the notion that centralizes or that kind of unifies the idea of like averages is the idea of, in mathematics, what's called a limit. So essentially what limits do, and the way the derivative ends up getting defined, is is the notion of an average. So you can definitely measure the change of a particle over time. That's fine, as long as you have some time scale. But the idea is kind of considering, what if you were to take more measurements, but in a smaller time scale? So what if you were to, instead of just taking it every 1 second, what if you were to do it every half second or every 10 second? Or
yeah, you would get closer and closer to the average.
Yeah. And as you approach an interval like where the time between seconds comes close to 0, then you begin to approach what's called an instantaneous speed. What do I mean that time is tenseless? It means that essentially the flow of time, so this notion we have of past and future, it's something that we observe to be, but it's actually not. It's an illusion, essentially. And that the language of relativity describes space and time as being essentially a continuous flow. It's a continuous it's a continuous space. There isn't really a way to define past or present without first creating some point of reference by which to say, I'm on this part of the sheet, and you're on this other part of the sheet. So from my perspective, it looks like your time is slower than my time, or something like that.
Nope, that wasn't very clear at the end.
So essentially, imagine for a moment that space-time is kind of like it's convoluted, but that it's a flat sheet that extends infinitely, right? Now, if you point to one random point on that sheet, right, you can't distinguish that you can't say with just that point, for instance, if that's the beginning of the sheet or if that's the end of the sheet.
Oh.
That point that you've chosen is completely arbitrary, because this sheet that's being referenced, like which represents space.
Yeah, you need at least one more.
Yeah, you need at least one more.
And you can say it's coming towards me. It's moving away from me.
Right, and you can describe the relationship of those two dots by however many spatial and time and space however many spatial dimensions and dimensions of time you wish to incorporate. And given at least 2 points, you can actually say something about, okay, well, point 1 relative to point 2, is to the left, so it's back in space somewhere. So when you have more than one point on this sheet, then you have a reference frame by which to kind of speak in the language of time as being something which appears to be going from past to future, some kind of directionality. But its inherent structure is timeless. If there
I haven't heard what you said for the last 2 minutes because my router cut off, but go on.
Yeah, essentially it's that you need more than one reference point to be able to make a distinction between the notion of where one point on a sheet is as opposed to another point on a sheet.
Mm-hmm.
If the sheet represents space-time. I think that's a sufficient explanation, but maybe Leo can do a bit better.
Yeah, it's like,
There's a reason why they call it relativity. You can be moving at 50 miles an hour through space-time. If there's literally nothing else for you to measure that speed, that motion, you won't be able to tell that you're moving.
Yep.
you
would still technically be moving, just no way for you to figure that out.
Try and think like a movie where a car is supposed to be driving, so they show the view moving. They show you, and as long as the view outside the window is moving, then you know the car is moving. Otherwise, it appears to stand still. If that works.
Yep. Oh, I didn't see Lena's earlier comment. Yes, so my claim is that time inherently is tenseless. I hold to the B theory of time, not the A theory of time. That's the one that appears to be.
I'd say the same thing, but I don't claim it. We've already experimentally demonstrated it to be the case.
Yeah, that's true. Whoops. I accidentally. Uh-oh. Yeah, I agree with you.
I'm not familiar with the tenseless conversation. Could you sum it for me real quick? Someone?
Yeah.
Tenseless time essentially means that time is not absolute. The time right now can be different depending on what you're doing, how fast you're going, if you're in a gravitational field. So we know that the clocks on our satellites, if we didn't continuously adjust them in a matter of one day, the variance on if you were traveling somewhere, but from the beginning of that day to the end of that day, the variance would be 7 miles because of how much faster those clocks tick than here on Earth, because they're not as close to the Earth as we are at sea level naturally, so they are not as affected by Earth's gravitation as we are. So space-time, to be more precise, is not as curved, as intensely curved, 14,500 miles above sea level as it is at sea level. So clocks tick faster. Just like as you fall into a black hole, a clock will tick slower and slower and slower. Yeah, that could only be true if time is tenseless.
So if time is, what's the opposite then? Tensed?
Tensed,
that means
yes. That means that the past exists, or the present exists, the past and future don't. In a tenseless time, all moments of time are equally real.
Let's see if I understand this correctly. If we're saying that time does actually have a tense, then when I say now is the same thing across the entire universe. Now is now.
Yes.
However, we know that our satellites, like if we want to find someone, where he is using a GPS, then we need to know where he is now.
Mm-hmm.
Turns out, now on the Earth and now just in orbit, it's not the same now. It's a different now.
Exactly.
The now for our satellites is sometime else than ours. This is a bit difficult to figure out. And the reason is gravity. Gravity changes space and time.
Yes.
So time, I think, moves faster, if I remember correctly, for our satellites.
Time is moving faster for your head than it is for your feet.
Technically, yeah, but yeah, that's a bit minor, I suppose.
Not very much.
If we don't adjust for that and think that the satellites have the exact same time as we do, the exact same time lapse as we do, we'll never find anyone. Ever. GPS will never work. because you'll have the correct location, but at the incorrect time.
Exactly.
So it's
And that's the
useless.
thing, is that people don't realize space and time are interconnected. The past exists. It doesn't still exist because the word still implies endurance through time up to the present moment, which is not the case. So the year 1932 exists. Not right now. Doesn't exist right now, but it exists somewhere in space time. Likewise, Germany exists. It doesn't exist right here, but it exists somewhere in space-time.
So
just
the
because I'm
argument
not
then
in
is
Germany
that
to
you
be
can-
experiencing what's happening in Germany doesn't mean Germany doesn't exist.
So by
Likewise,
your
just because I'm
analogy-
not in 1932 to be experiencing what's happening in 1932 doesn't mean 1932 doesn't exist.
So according to your analogy, I can travel to 1932.
No.
No,
Well, but I can travel
Would
to
it be-
Germany.
Yeah, because entropy moves across time, not space.
So, okay, so maybe my conception is wrong, but so would it be, as a conceptual model, I guess if you're doing something like stitching or like layering for like fabrics, for instance, what you might try to consider is, like, one way to consider this is that if you consider something like a record keeper or something like that, the process of space-time and its evolution, meaning changes in things that happen to the entirety of space-time, would be kind of like having different molds kind of being subsequently laid upon each other, where the differences in those scaffoldings and moldings being different intervals of time. Maybe
Hard
that
to
makes
explain
sense to me.
without math.
Yeah, it is.
Mortimer X81 has some good explanations on this stuff, like the arrow of time and
Yeah,
such.
Marty's got some good content.
Yeah.
Yeah.
The Science Asylum also has good content on this as well. I think he's got a video. I'm pretty sure it was from his channel that I watched, something where he talks about time and stuff like that.
I guess
So,
the only question-
Mortimer's advantage is that his profession, he's a teacher, and his master's is in not metaphors, analogies as an instructional tool. That's what he did his thesis about. So when he teaches something, he's really good at it, and he gives really, really good analogies.
His videos addressing the I would argue rather absurd claims that William Lane Craig makes about relativity are just fucking perfect. Because we have to remember, William Lane Craig is the guy who pretty much says that special relativity and general relativity aren't exactly correct. Also, that he can rescue the notion of absolute time and absolute simultaneity so that he can argue God created the universe.
I mean, he's not, well, that point he's wrong on. I mean, we know because of quantum mechanics that general relativity needs revised, but
I don't like the word revised. I prefer to say that general relativity needs to be added onto, but everything that we have with it now is 100% accurate. We just don't know how to apply those equations in terms of quantum scales, the energy levels that exist at those scales. I mean, mainly because the curvature is practically non-existent at those scales.
Yeah, but the thing is, like, if quantum mechanics describes it describes space, for instance, it describes energy also this way, but it describes it kind of as in a way kind of like being a ladder, if you will, where they're discrete, they're discrete intervals of energy, they're discrete units of space, and there's a certain distance between rungs of those ladders that are relevant for quantum systems. Whereas with space, for instance, like according to general relativity, it describes space as being entirely continuous, that there are no gaps within that structure.
Yes.
And the same thing for
That's
time.
special relativity.
Yeah.
And that the thing is that just base level quantum mechanics doesn't even talk about space-time. Space-time doesn't even exist in base quantum mechanics. So when you get to relativistic quantum mechanics and you bring in special relativity, that you're that you or if you're like in relativistic quantum field theory, that's when space-time has some coherent meaning. But other than that, like if you're taking an undergraduate course on quantum mechanics, space-time isn't relevant to what you're learning.
No, it isn't. It's completely irrelevant. It's only when you choose to, because one of the assumptions behind basic quantum mechanics is that the speed that objects are traveling are not close to the speed of light.
Yeah.
They're at a low enough speed that it doesn't begin producing relativistic effects.
Mm-hmm.
Whereas in quantum field theory, among other things, that's where those perturbations become relevant.
Yep, and that is why we have to learn perturbation theory.
Yeah.
And it's not fun.
It's a valuable tool, but it has it can be a little tricky to use properly.
Yeah,
because of what it does.
I gave up late last year trying to learn it, and I figured, you know what, fuck it, I'll come back to this when I know more.
Yeah, I mean, it's essentially like it's an approximation. It's
Yep.
like it's representing something by means of an infinite series, and you can manipulate that in different ways, but wherever you choose to insert that into the equation, I mean, because that's your choice, right?
Mm-hmm.
You end up kind of masking away something about the problem. Something you can't, like with mathematics, nothing ever truly disappears. And so when you introduce a parameter to try and make something work, you have to be careful with that, because the original problem is only true in a certain case of that parameter.
Yep.
Whereas what you're trying to find is the general solution, not one specific state you can solve.
Yeah, exactly.
Okay, I think, guys,
What?
Very esoteric areas, and it's getting hard to follow you guys.
This is the second time that Smokey's beefed with Praise, isn't it?
Yeah, I think so. And this time, Praise was biting back at Smokey. Because Praise was doing a live stream last night.
People.
What?
Praise and Smokey are two of my favorite people. What happened between them? I'm dying to know.
I don't really know.
Dish.
I feel like it has something to do with Praise not accepting fully Trinitarianism or some part of it or something like that.
Yep. Essentially.
So is Praise a non-Trinitarian, or is he a Trinitarian, just not the way that Smokey wants him to be?
No, Praise is not a Trinitarian.
Okay.
It's your point of theology, and Smokey always thinks he's right about everything, and everyone disagrees with him. Moron.
Because in his mind, he is right about everything.
Endearing traits.
There is time in quantum mechanics, not space. Or I should say space is significantly more abstract in base quantum mechanics. You just deal with Hilbert spaces, not actual space-time. But time is a fundamental property in quantum mechanics, like position, not really even position, more like momentum, energy, time. Position doesn't really mean much in quantum mechanics because it's not a conserved quantity, so we just don't really give a shit about position. We speak more in terms of energy and momentum.
Yeah. Momentum, let's see. Yeah, momentum, energy, time, and there's another one.
Spin. Well, spin, not really. Well, I guess kind of. Spin's one of those ones that can get a little tricky.
Yeah, well, actually, no. Change in position is one that's conserved. Change in position, change in time, change in position, change in time, change in momentum, change in energy are the quantities that are that have inequalities related to them.
Mm-hmm.
And I want to share that I'm cutting a particularly vindictive onion, and I'm in pain right now.
I know. Apparently, Lena has a question about the delayed quantum erasure experiment.
Yeah, that's what I was talking about. is that there is time in quantum mechanics. It's just space. I should have been a little bit more accurate. It's not that there's no space-time in quantum mechanics. It's that we treat space and time not really as the same thing. We treat space as more abstract, and time is more, in some ways, fundamental.
Yeah.
Where time is just another property that things have, but space, at least, and again, this is in base quantum mechanics, is more abstract and represented by something called a Hilbert space.
Yep.
Is that the same Hilbert from the hotel?
Yes, David Hilbert.
Yep.
I see.
He's a freaking brilliant mathematician.
Also responsible for I think they're called Hilbert curves, but space filling curves.
What curves?
I think they're called space filling curves, but they also might go by what's called Hilbert curves.
I don't know if I've heard of those, honestly.
Let me make sure it's the right thing. They're related to the concept of Hilbert spaces, I think.
I did want to also say it seems like Smokey was trying to get Nicholas against Praise as well. So I messaged Speed and told him that if for some reason the beef between them fucks with our debate that we're supposed to be having, I'll get a hold of Praise and see if he wants to team up. I'll see again if he wants to team up with Maddox, or maybe he wants to team up with Neffy. Because I know Neffy likes to talk about this stuff too.
Let's see. Okay, can we talk about the retrocausality and the quantum eraser experiments, because the distance is different?
What?
Hey, guys, I'm gonna go because my internet keeps crashing and I keep losing you guys.
That's all right.
So, have fun. Love you. Bye bye.
Love you too.
See you, Manny.
Bye.
He's never around, and then when I finally get on a stream with him, he leaves.
The only time retrocausality usually comes up is like when you're talking about entanglement. And usually, I mean, I typically think retrocausality only makes sense in terms of the many worlds interpretation of quantum mechanics. Oh, Demeter wants in. Let's see. Let me post the link. Michael, you're still here. What are you doing?
The first thing I wanted to point out is that the quantum eraser experiment and the delayed choice quantum eraser experiment are not the same thing.
Yeah, they're two different.
I know more about the delayed choice because I hear that. I've just heard that more often, so I've read more on that one. I honestly probably couldn't explain the quantum eraser, not because I don't have the understanding to explain it. It's just that I haven't really read on it much.
Demeter,
So when you say quantum eraser experiment, you're talking about a thought experiment, right?
In a sense, yes.
Okay.
So the delayed choice quantum eraser experiment asks, if we measure a photon that's been moving through space-time for billions of years, and we pick it up in a detector, we measure it as a particle. But if we change the detector so it shuts off, so it won't actually detect that individual photon, then it'll appear as a wave. So when we shut that detector off, did we change the entire billion-year history of this photon? No, because the photon, before it was ever measured by the detector, whether the detector's on or off, was not actually a wave or actually a particle. It was in a superposition of states.
Very clever.
And a lot of people try to use, like John Maddox, who doesn't understand quantum mechanics, at least very well, try to argue that it shows retrocausality is a real thing, and it definitely doesn't show that. I'm going to go backstage. Give me about 3 seconds so my camera turns back on.
Yeah, I did have a question about that then, in that case. One sec.
Now, I've heard SFT use the idea of retrodiction a lot in some of his discussions with other creationists. Is that this? Are they trying to apply the same thing, or are they just talking about like making predictions about things you're going to find?
I wanted to ask Leo a different question, but I guess he can answer to that first.
I don't know what retrodiction is.
Retrodiction is the idea that to account for something like that we observe in the present, something else has occurred in the past to permit that.
Well, that's literally the whole of how the physical sciences work.
Yeah, I guess
that's the thing with standing. Standing just denies the basic tenets of science because science fundamentally disagrees with almost every point of his worldview.
Yeah, I guess the question I was going to ask you in the case where they tried to measure the particle as a wave and then as a and then actually being a particle, it does. I mean, and I kind of think this a little bit, but that the particle has some kind of not inclination, but some kind of how do I say this? There seems to be certain situations like where the thing you're describing, so some quantum particle seems to either like choose between whether or not it wants to behave as a particle or as a wave. It doesn't always seem to like behave as a wave or particle simultaneously.
No. See, and that's something that I get like when here's a particle can be in two places at once. Literally fucking nothing in quantum mechanics says that. That is a gross oversimplification of what happens, and I really wish that literal PhDs would stop wording it that way. A superposition doesn't mean all states are being held. It means that there is some probability this thing could be in any one of the states. We have ways that we can assign probabilities to each state and then determine which of these states it is most likely to be in. If we actually do make an actual measurement in the actual real world, then this object, we'll say this quantum object, will have to be in one of those states, and we can determine which one it's most likely to be in based on the probability that we assign to it.
Yeah, that's unusual because I've typically heard, like even PhDs will say it, that when you're talking about a superposition of states, so states that are solutions to the Schrodinger equation or some modified version of it, that there's state A and there's state B, each of which are solutions to the Schrodinger equation. And since the Schrodinger equation is a linear differential equation, the sum of states, or the superposition of states, as they call it, also is a state that the particle can occupy. So, and there is like physical disagreement in wondering about, does that mean that the particle is actually occupying both states simultaneously, and once something is done to that particle or it's perturbed somehow, it settles on a state? Or do you just mean that there's an indeterminacy between which state it's actually in?
When you say indeterminacy between which state it's actually in, are you asking, well, not really, I guess, what much of a question, maybe it was, is that something along the lines of, well, a particle is always actually doing something, but we can't ever know what it's doing. We can only know the probability of what it's doing, because that would be something along the lines of pilot wave theory, which states that, yes, particles are always actually particles and they're always actually doing something. We just don't know deterministically what they're doing until we measure them, which we've already shown with, I believe, Bell's experiments that, yeah, that's not true. It's not that a particle is doing something and we just can't figure it out. It's that it's literally not doing anything until it's measured. Well, not doing anything. Okay. I want to put that in quotes.
So I guess for me, what I would say is that it appears that particles are always maintaining superposition of states. And the reason I say that is mathematically, right? Mm-hmm. If you say that something collapses to a state, right, one of the solutions to that equation has disappeared because one of the states is being quantized. But after a different moment in time, right, it seems to re-enter a superposition of states. And so for me, it's a matter of mathematically, how do you do that? How do you say that for some particular moment in time, it settles on, either solution A or solution B, but then a split second after that, right, it re-enters a superposition of states.
So how do you do that?
Yeah, like how do you
collapse the wave function?
Right, but that's not the issue, right? It's not an issue of collapsing the wave function. It seems to be restoring superposition, right? Mathematically.
I don't see. I guess I just wouldn't use the word restore.
Well, when you break superposition, right? One of the states, right? One of the eigenvalues takes on a value. Mm-hmm. Like it becomes quantized. Whereas if it's not being measured according to superposition, it doesn't have an eigenvalue associated to it yet.
Exactly.
Because it hasn't broken superposition. But so it means that if there's potentially, say there's 3 solutions that satisfy the Schrodinger equation for some particle, right? Once you have one of those eigenstates that are quantized, the other 2 vanish. They go to 0.
Yes.
There's an 100% probability of viewing that particle at that time. But a split second after, you return to a state where, again, you have 3 eigenvalues, but that they're unquantized again.
The only way I can really explain this is with an analogy, but the analogy kind of sucks because I can only use analogies that exist at the classical level of reality, but it kind of explains it. Here, let me just do it. So imagine that you have 2 people throwing a ball behind you back and forth. You're not looking at the ball, you don't know where the ball is, and we have to ignore the fact that the ball is actually someplace and you just don't know where it is, because that's not how it is in quantum mechanics. But obviously this is a contrived analogy. The act of making an observation would be like you turning around and seeing the ball someplace. So when you turn back around, the ball goes back into a superposition, but it's not like it chooses to do that. That's just the way that nature fundamentally is. So everything is always in a superposition until it's measured, because when you measure something, it can't be in a probabilistic distribution of states. It has to be doing something. So every time you turn around, that ball could be in the process of being thrown between these 2 people. You could always measure it to be in the same position, or you could measure it to be in different positions. Now you can assign a probability to all of the different places it could be between the 2 people, and the act of you turning around is sort of
So I mean, my solution to
it
that
would be like collapsing the wave functioning and figuring out where it actually is. Yeah, and this is the thing, because particles, the quantum level of reality is just inherently deterministic unless you make an observation.
So I guess the only question, or the only hypothetical I would raise against that, or kind of like push a little harder against, is, would it not be simpler to say that, yeah, that's going to be a little bit of an issue. I guess for me, it's easier to say that a particle never truly breaks superposition, in the sense that it seems to always be in a constant state of flux between solution 1 and solution 2, and whatever states those correspond to. Mm-hmm. But it's fluctuating in such a way that it's random, that there is no determinacy between, to tell, like, okay, it's going to be A, B, A, B, A, B. There's no algorithmic process you can use to predict that. But those states do exist. It's a matter of measuring them, to me.
Oh, yeah, the states exist.
Yeah.
But we just don't know which one the particular object is in. Well, right. The thing is that it's actually not in any of the states until you measure it.
Yeah.
So one way that it was worded to me is that you can imagine, instead of an object being in one particular state and we just don't know which state it's in until we measure it, because it's not in a state and we just don't know it's not in a state at all. You could say that there's some percentage of that object exists in all of it. And obviously this is a bit contrived, and he expressed that, but said that it kind of helps people to understand that there is some percentage of that object in that state. The larger the percentage of the object in that. So you could say, well, 40% of the particle is in this state, 20% of it's in this state, 20% of it's in this state, and then 20% of it's in this state. And that's based on the probability of finding that object in that state. The higher the probability, the larger the percentage of the object is in that space. And again, I understand that is quite contrived, but it somewhat helps make
I get
what
it.
A superposition is.
I've heard that too, and I've argued with professors about that too, but I won't go on for this.
Yeah, and see, that's the thing, is because you'll hear an example and you're like, but what about this and that? Because giving analogies, the professionals try to give an analogy in an intuitive way, but quantum mechanics is not intuitive. So you have that divide there, and that's where it becomes
when I argued with
talking about it.
When I argued with people, that's like, okay, in that case, can you show me 37% of a photon?
Exactly. It's show me 37% of a photon. That doesn't.
I'd like to see that, really, because that's an interesting claim that half of it's distributed here and the rest of it is somewhere out in the Andromeda galaxy, God knows where.
Yep.
Now, I might have missed part of this because my dog was wanting my attention. Are you saying that scientists think that 40% of a particle is in one state? And
Oh, no.
20%
No. That's a
was
joke
praise?
between.
Oh, okay. I thought you were saying praise said that or something.
A
No,
more
that's
literal
Okay.
way is that say a quantum object like a photon has a probability of being in, say, 3 different states. That probability is 100%, but the 100% probability is distributed over the states in an unequal manner. And we can represent the distribution of that probability with what we call a wave function.
Yeah.
And it's going to be in one of those 3 states
Only
entirely.
when you measure it.
Okay, gotcha.
Otherwise, when you're not measuring it, it's probabilistic, and those probabilities are distributed, sort of smeared across all the states.
Okay. Okay. I said that was the last question, but this is on for the last question. Since technically in the language of mathematics, a superposition of states is a solution that spans a differential equation. Would a superposition of states be a 4th solution if you consider the example we've been using of a state that of a typical description where normally you have 3 independent functions which satisfy it, but now you generate a 4th since all 3 being summed is a solution?
See, I've actually asked myself that same question, so I don't know if I could provide an answer to it.
God, fuck.
Where's Sean Carroll when you need him?
Yeah.
That's what I always ask myself.
Where's my date with Sean Carroll when I need it?
Yeah. Or Leonard Susskind. Where's he at?
Yeah, there we go.
I was going to ask Dimitri, since he's here, have you solved all the problems of abiogenesis yet? I was just wondering.
Let's move on to something that actually makes sense besides quantum mechanics.
Yes.
Yeah.
Yeah. Well, in abiogenesis, the logical things are more logical than whatever it's in the quantum mechanic. So, to me, the origin of life, in principle, in general, theoretical, it's solved what's supposed to be. But of course, there are lots of details. So if you have any questions, and if I can answer, of course, I will answer.
My problem is I'm trying to get to a point where I can understand even the questions to ask. I'm trying to get beyond my first year of college biology class that I had over 30 years ago to understanding what's going on in biology and tackling that whole issue about biogenesis. It's real interesting, and I need to be able to be fluent in that talk.
Yeah, I understand. So from your biological classes, you need to know what is translation as a process. Also, you need to know what is replication as a process, and some of the mechanisms, how they are performed, what actually some of the details are important. But the most important is you to understand what is all about, like a process. And then you can ask the correct questions. For example, nobody can ask the correct questions for origin of life until 1973, probably, when was the genetic code was kind of solved. And then you can ask, indeed, the real question, how the origin of life came to be, just because you know what is the translation, you know what is genetic code, and you know what is replication, and what is transcription, of course. So I just want to share a few things before someone might ask more questions. So finally, I published all of the 3 papers that I wanted to be published. Those 3 papers cover almost 99% of everything that I wanted to say or to share with the scientific community about the theoretical part of the origin of life. So if someone want to see in details these 3 papers, could be done. The best way to read these papers, it's in this way. Let me share just for a briefly, just to share the screen. So let's see. Just 1 second to see how. First. Okay, so I'll share the screen. All right. So if someone wants to read this theoretical part for origin of life, he's supposed to start with my last paper, which is this one, Origin of Life, the Point of No Return. In this paper, what I'm presenting is actually what we are looking for in order to figure it out what the origin of life is. There is a definition for what the Darwinian evolution is and what the life is by itself. And of course, in this paper, I'm presenting how and what's supposed to be the, let me say, not the best, but accountable or trustable hypothesis for origin of life in this paper. So the second paper that I would like to someone, if you want to read, so he got to go through the second paper. Is it changed? Yeah. So this is, so you're supposed to start with the paper that is the last one. Now, if you want to continue, the best way to continue to read is from the first paper that we published. And this is this one, where the actual hypothesis is laid down. So this is the paper mainly dedicated to the actual hypothesis and dedicated mainly to the RNA peptide world. And it's explained very clearly, step by step, in a relatively clean language, how and what is all about. And of course, the last that it's nice to read once you come here, once you finish with this paper, okay, is this one, which is the last, that we published this year, the beginning of this year actually was published, but this paper is kind of coming after the hypothesis, meaning is described what happened and how the actual genetic code started, how the information started, and how the evolution of the genetic code went through the more chronological way. And this is what, okay, and this is the 3 papers which cover the entire, I will say, theoretical field for origin of life. What is life? What is the best hypothesis? What we can looking for, and how the genetic code happened to be. So, I mean, from that moment, I cannot say anything because, meaning I cannot say anything theoretically to the field. Because the next logical, of course, move is experimental. So we have to go and just do experiments. So if someone has some kind of urgent question about origin of life, we can discuss it. Or we can schedule another time for that purpose. I have
a few questions that shouldn't take too long to answer, but we can obviously continue this later if it takes too long to do it in a stream like Saturday or Sunday or something like that, or whenever. But so I guess one of the questions I have is looking like looking at modern cells, we know that modern cells have, for instance, very organized compartments in terms of their ability to catalyze certain reactions. So the mitochondria is responsible for fixating ATP, stuff like that. So I guess two-part question in this case. Number one, would protocells have any nuanced form of compartmentalization? And number two, if there weren't any originally in this protocellular system, what would be the driving force for it to develop, for it to evolve?
Yeah. We don't know lots of mechanisms what actually happen, and that's for sure. We can only do experiments. However, what I can say, compartmentalization is almost absolutely necessary to be present at the beginning of the entire story. But there are lots of niches for compartmentalization in the primordial Earth conditions. The actual, for example, if you go in Hawaii and observe the current volcanoes, for example, you will see the basalt rocks that it's formed in the water. You will see how many porous is this basalt water. It's full with lots of, like a sponge. It's lots of porous inside. Also, there is primordial early sedimentary rocks, which could trap lots of organics also underneath. And definitely compartmentalization is almost absolutely necessary for the process. Also, in all of the experiments which try to simulate the prebiotical chemistry, you see that the building blocks of life, of course, are absolutely feasible. They appeared, like nucleic acids and amino acids, but also there is a lipids part of the same process of prebiotical synthesis. And the lipids tend, everybody knows that, it tend to make a spheres, tend to compartmentalize. They tend to trap some organics inside. So from the point of view of compartmentalization, it's if we don't know the actual details, at least we are sure that it happens.
Right, and I guess so to inform people, most prokaryotes actually don't have. They exhibit some level of compartmentalization, but overall not horribly much. They have a few compartmentalized regions. Some of them are hydrosomes, so they're responsible for import and export of water, maintaining certain things like that. Others are responsible for maintaining charge balance and certain charge concentration within cells, which that's fine. But there is one interesting thing, which is that, so even once you have lipid systems, for instance, like in certain bacteria, there's certain, I guess you could call them post-translational modifications that are made to those cell walls. So for instance, one that's very common within most prokaryotic organisms is a modification called NAM, or NAM for short. And that is represents a particular sugar linkage called N-acetylmuramic acid. And the question, of course, being, number one, I guess, it's because it's a ubiquitous phenomenon within all prokaryotes. Well, almost all prokaryotes, I should say. Why is it so specific to, why is that particular modification so specific? And would it have been present, at the origins, or would it have, again, evolved later?
So here is what is known. First of all, as you said, it's a modified variants. They also used amino acids to make a polyamino acid. For example, glycine, polyglycine, or polyglutamine, or other amino acids. It's also what is very interesting. Some of those are not not left amino acids, or even right amino acids. So it's a not. This is a process of polymerization of amino acids, which is not genetically predisposed. It is not coded. It's not coded amino acids. So you can imagine there is no coded amino acids part of the canonical amino acids which are right, for example, D-alanine, for example, or
Right.
But in these walls,
or
in these walls, they're widely used. And also judging for the fact that are not present everywhere, this is more like a specific development to make the walls a little bit more stronger, let's say this way. It's more stronger, but mostly for the prokaryotic organism, for bacteria. It's unlikely to be any mechanism of initial compartmentalization, because it's whatever it's happened is established at the beginning in the first protocell. It's more likely happened to stay for all of the domains of the life, not just specifically for one branch of the life domains. So this particular evidence or this particular data does not give us specific, I don't think it gives us any specific addition to us in order to understand actually what indeed happened. The reason that I published the last paper is to stress out and to emphasize very clearly what supposed to looking for when you're looking for origin of life. And this is the beginning of Darwinian evolution. Because if you don't have information structure system, there is nothing. You cannot make anything further. You cannot complicate. You cannot have anything that can become life. It's simply like that. You might have, it's quite possible to have a just physical chemical structure, let me say polymer, some polymer, which is very stable. For some reason, it's happened to be very stable. And that might influence the origin of life, but it's not life per se. It's not the same as life, because even if it's very stable, it will not go further. It will not complicate. It will not be able to upgrade. And that's what is the main core of this last paper, to say to the people, to the entire scientific community, I want to say, guys, don't lose your time. I mean, okay, you can do all kinds of study and search and so on, but when you're talking about origin of life, you should be focused exactly on the beginning of Darwinian evolution and nothing else. So,
yeah, I guess the last question, and unless Lena has other questions, like the last question I would have is to think about, for instance, so we know that modern cells, like especially modern eukaryotic cells, are tremendously more complicated than Luca. They're also tremendously more complicated than prokaryotes for a number of reasons. But so the question, I guess, and this depends on the level you take it at, if you do it from biochemistry or molecular biology. The question, I guess, that should be asked in addition to the fundamental processes is that, is there some distinguishable level of molecular complexity or biochemical complexity we can identify within cells or even like protocellular systems that kind of gives us a way of seeing what things are what things are closer to becoming life and what things are more, I guess, more distal to becoming life.
Yes, so this is more like the question how we know what life and how the life started if you start and if you're looking from up down approach.
Yeah.
So indeed, I mean, definitely eukaryotic system is very complicated. Prokaryotic cells are also very complicated, and all of those are very much more complicated than LUCA by itself. So we know a lot about LUCA, and we don't know a lot about LUCA. So LUCA, how we know about LUCA actually, and why we are so sure about the existence of LUCA. Just because of the approach from up to down. If you try to analyze the genes, all the genes from all of the domains of life, you will see there is a common genes which are presented in all domains of life. And this is one of the definition for LUCA. So for example, the genetic code, although there is a modification, yes, there is some variation of the genetic code, but the genetic code almost is the same in all domains of life. So all of the genes, and you can trace that actually, those kinds of study, bioinformatician did the study. For example, if you look names like Eugene Koonin, there is also another recent studies, and they try to figure it out how many genes have LUCA, should have LUCA. And the estimation is about 300 genes. Between 300 and plus minus, for example, 50, 60 genes. We don't know exactly, but this is the genes which are predominantly responsible for the translation, like ribosomal genes, tRNA genes, all of some of the proteins which are responsible for translation, like amino acid synthetases. Also, this is the genes which are responsible for the replication, RNA replication, which it's happened to be today mostly specific for the viruses, but also for the DNA replication, and some metabolic genes, like all the genes, for example, connected with the Krebs cycle. So having all of these genes, you can analyze and make alignment, and you can see the phylogeny of those genes. You can trace it down, and you see a core, a very specific core with about 300 plus genes, which are common for all domains of life. And this is very clear, and there's no doubt. So at some point, we are sure that there was a LUCA. However, that doesn't mean was kind of absolutely one LUCA immediately at one single point. That means that there was a common consortium, common network of LUCA, which give rise to all of the domains. But even LUCA is extremely complicated. With 300 genes, it's already a very complicated life. So when you're going even down from the LUCA to the actual origin of life, this is terra incognita. So it is completely new world for study. Nobody knows exactly how and what happened in all of that, what kind of processes occurred and was stabilized, evolutionary stabilized, in order to go from the first initial Darwinian evolution event, which I'm calling Terra Darwinia. This is the first organism. It's called Terra Darwinia, to the LUCA. So between Terra Darwinia and LUCA, you have establishment of approximately 300 genes and primitive metabolism, and that.
Yeah, so this is the last thing I'll say because I actually have to do some things.
Yeah, I gotta
at the
take
work.
off. I gotta get ready for.
Yeah, no, I gotta. All right, take care. But yeah, I also have to do some things. But I'll leave it at this, which is that it should be noted that the phylogeny has its limits. For me, there's two very evident reasons. Number one is that definitely it's true that after prokaryotes and eukaryotes began to exist, they started doing their own thing and having progeny and started modifying and kind of taking off in their own, little directions, having their own adventures up the tree of life. However, towards the roots of the tree of life, there's something which most people would consider non-life. Actually, not even true. Some people consider life. But the major component that we overlook are viruses, and that is that viruses are able essentially in the role of evolution as a way of kind of transporting genes. They have genes of their own that they have genes of their own, and they have genomes of their own that they will transport and infect into another cell. And so it may be the case that viruses play a critical role in terms of the origin of life from transferring genes that they've acquired that other organisms like Luca cells have never seen before. And it also makes sense that what you're calling Terra Darwinia, to me, seems to be more of a type of organism in the sense of a population, being that, for instance, if you take, for instance, organisms or bacteria such as methanogens, right? They live very, very close to ocean, very, very close to areas that are very warm. They live very close to volcanoes, and as methanogens, they manipulate methane as a resource. And so, if Terra Darwinia organisms are there, they are going to use systems that are proteins or protoproteins that are kind of adapted to that function, or that are adapted to whatever resource is most available. And so for me, I think that the notion of viruses kind of being a vector by which to essentially share genes or enhance the diversity of the genomes that these Luca organisms have seems to be a very critical role. Although, because viruses compete with each other for organisms and trying to replicate, that can be quite the challenging process to figure out.
So, okay, so there's several questions here.
Yeah.
First of all, just to be clear, Terra Darwinia is the first organism which it's happened directly appeared from chemistry.
Right.
So Terra Darwinia, it's not anything more than a few amino acids and few nucleotides. I mean, don't think for Terra Darwinia as a complicated organism. Terra Darwinia is just have one specific feature to be capable of Darwinian evolution. This is the only feature of Terra Darwinia. And this particular feature of Terra Darwinia is held only with a very short peptides, 1 or 2, and very short RNA. And that's it. So this is the simple possible ever life that you can think about.
Right.
So this is Terra Darwinia. That's why I'm calling Terra Darwinia is the first organism immediately appeared from the chemistry. So, in the past, historical philosophers, natural philosophers, always was thinking about life as a self-generated every day. You have self-generated every day. For example, maggots from meat and those kinds of things. And Louis Pasteur, of course, came and completely provided experiment that disproved this even idea. However, back in the origin of life, there was indeed one organism that was how was the term? Self-generated or appearance. So this is the organism which is directly from chemistry to the biology. So the very first organism, and
Right.
that's Terra Darwinia. So from Terra Darwinia to the actual Luca, you have many stages. Many stages. The first stage is the period of time which we call it RNA peptide world. And after that, you have you always have evolution from short peptides to longer peptides to proteins, and you have development of the replication complex, and you have developing of translation machinery all along the way. And finally, you have approximately 300 genes plus minus as a lookup. But this is a huge gap. You can imagine between Terra Darwin.
Pardon the interruption.
Hello.
Yeah.
Yeah, sorry, overhead speaker.
Okay. So, and this is a huge space between Terra Darwinia and Luca. It's a very long process of evolution. Now, what about the viruses? A virus is a byproduct. At the very beginning, of course, when you have protocell formation, and we can very securely assume that protocells was in existence, but these protocells was not steady state like the modern cells. They was constantly popping each other, merging each other, separating each other. It was like a network of protocells, something like that. In this process, you have a process which we know from the molecular biology. It's called horizontal transfer of genes. And this process of horizontal transfer of genes is absolutely common, and actually was much, much more common in this period of time between Terra Darwinia and Luca. And that process, of course, some of the units of genetic units might emerge out, and they can have kind of dormant life for a while until they emerge to another protocell. So, and this is the beginning of the viral of the viruses. They are clear, obvious byproducts from the already formed cells. There's no other logic for this. So, I think the very first viruses, the RNA viruses, which are exactly the COVID virus. COVID today is RNA virus. So, and it demonstrates relatively very stable. It's a very stable. So, did I answer your question?
Yeah, you did. This conversation could go on for an eternity. There's a lot of open questions in the field of abiogenesis, and there's still interesting gaps that'll be filled in eventually.
Yeah, of course. I mean, the research, it's just the beginning of the actual research, because once you have idea what actually you're looking for, you can perform the proper experiments.
Yeah, and I think that mostly it's going to be an effort to kind of unify these theories of metabolism first, lipid first, and replication first. These general frameworks.
I'm not quite sure about the unification of this because there won't be a process. That's my personal opinion. Of course, every scientist might think differently, but my personal opinion, there will not be unification, but more like will be kind of consolidation, meaning, for example, if you take metabolism first hypothesis, there is a place for this hypothesis, but most likely to describe the prebiotic conditions. Meaning, this is a way that some kind of they describing a process is how some of primordial blocks of life could emerge in more complicated way. But this is not a hypothesis which can describe the formation of Darwinian evolution. The main problem of metabolism first hypothesis, for example, is that there is no way based on just this hypothesis to figure it out how the informational source appeared. So and also there's a variety of metabolism first hypothesis. So the clear metabolism first hypothesis actually was provided very long time ago in 1923 for the Russian scientist Oparin. He was the guy actually that provided the first wonderful hypothesis for origin of life back in Soviet time. So, and his hypothesis was taken, but he even didn't acknowledge the existence of the formation of information until the end of his life. Another guy, which was Mueller, I think, which provided another hypothesis, which is called living gene hypothesis, or living enzyme hypothesis, or living gene hypothesis, which was the beginning of replication first type of hypothesis. So, bottom line, if you think about metabolism first hypothesis, they said like something, for example, you have a process where the primitive metabolism occurred before information era. So you have a metabolism, let me say Krebs cycle. So you have the Krebs cycle going on in different directions, of course, naturally, and that somehow happened to be alive. So unfortunately, I don't buy that. I didn't buy that. The second variation of metabolism first is the hydrothermal vents hypothesis. So because the ocean, the water around in the ocean was more acidic, so the hydrothermal vents by itself are more alkali. So you have a natural proton gradient from acidic to the alkali. And this proton gradient resembles somehow the proton gradient in the modern membranes in the, for example, if you go mitochondrial membranes for ATP synthesis, for example. And they said, okay, this is the same situation as it happened in the living organism. Therefore, this is the beginning of life. No, it's not. Because the hydrothermal vents, first of all, they're underwater. So being underwater is very difficult to polymerize. If you're underwater, you might have monomers, synthesis of monomers, but these monomers are not in condition for polymerization. Simply because in order to polymerize, you need to remove water. So underwater conditions, it's very difficult to think about that. Also, I don't see any difference between the beginning of Earth's hydrothermal vents and the modern hydrothermal vents. They must be almost the same. So, therefore, you can just conduct experiment, go down, and see how the life is formed directly in situ. I don't think that is happening. So, and there's several more kind of not very convincing metabolism first ideas. Even so, I acknowledge metabolism first concept to the point that they can explain some prebiotic formation of some building blocks of life. So, and I don't even want to start right now to talk for RNA world hypothesis, because this is another hypothesis which is how many years? 30 years in domination. So
right. I think perhaps at some later point this month, maybe even this weekend or something like that, we could kind of run through the history of some of these hypotheses and see.
Yes.
So that way people have an idea of kind of their historical significance and where some of these newer ideas and newer theoretical models are trying to take the field. Yeah.
I mean, it's up to you. Immutable, you can schedule anytime, for example, this Saturday or Sunday, let me say sometime around 12 o'clock. For example, something, I don't know. I mean,
yeah. I think that'll work. But yeah, I'll be sure to get something to work. I'm not sure. My schedule's been fairly touch and go. Although this has been an excellent stream, much better than I thought it would turn out. Thank you all for stopping by. We had quite the interesting, broad-spanning conversation, starting at quantum mechanics and somehow making our way into abiogenesis and the wild mess of theories that are competing with each other, but not nearly as bad as the almost century-long conversation now about which interpretation of quantum mechanics is right.
Yeah.
I just stopped by to say goodbye to y'all. I guess you're ending right now. I was distracted. So
yeah.
Hi, Lena.
Yeah, Lena hasn't talked.
Hi, everybody. Здравей, Димитър.
Здрасти, какво правиш?
Добре съм.
Yeah, you too.
Yeah. Oh, wow. We're getting along just great. Well, I hate to break up the love party, but unless Speed has something to say, since he does own the channel, I'm going to end it.
Yes, this is my channel, and I resent the higher production values. Demeter, I will try to be there on Saturday. We'll see what my head is in and out of the normal sphere here lately, so I'll see what I can do.
Okay.
Yeah.
And it's up to you. You know best what to do.
We'll take care.
Well, it'll either be Saturday or Sunday, and we will definitely keep in contact to see which of those dates it's on.
You can invite more people. Just around.
Yeah, I think I want to keep it constrained a little bit to maybe like 4 to 5 people, kind of like the way it is now. That way, there's not too much. There's not too much competition, or people feel like if they do have a genuine question about your theory, there is an opening for them to be able to insert and inject those concerns or those points of clarification that need to be made.
Yeah.
And Smokey is complaining about having too many channels talking about him, so let's not talk about him anymore. We'll we want to relieve his burden.
Yeah, he was pretty much irrelevant after we got started, so he just came in late.
Unfortunately, I'll have to mention it. This has been the morning report covering not the Unholy Triune, but apparently Smokey has been such an observant listener that's what it became anyway.
I love that they're all smiting each other. The Christians are smiting each other. That was what Praise did on the stream. Anyway, I want to say to you guys, thank you so much for running my channel while I'm dealing with my thing. Okay, thank you.
Well, somebody has to fight the good fight.
Only one question. This Q&A session, it will be on Speed of Sound channel.
Yes, it will be.
On Saturday or Sunday?
Yeah, we're not sure which yet, but either Saturday or Sunday.
Okay, but you will somehow let us know.
There will be maybe as early as Friday. Well, it depends how Speed's feeling, but there should be an announcement or some kind of way, like it was earlier today. There will be. you will see that, like, going live at 2 o'clock or whenever it happens to be.
Good.
I guess you could also tweet an announcement.
I guess so. I'm gonna have to hire John as as an assistant project manager now that I'm actually having to do production management for Speed's little project here.
Okay, because I had no idea that the third paper is out. I have just
Yeah, later on, either I or Speed will update the description section with the papers.
Okay, no, I have found it. I had no idea that it is out, and I have just checked it. It has been published on the 3rd of November, if I'm not wrong.
Yeah, it has. It's been published relatively recently. So,
well, I plan on reading every word of them. I don't know that I'll understand any of the words. I'll give it a whirl.
Oh,
I understand the half.
I'm sure after many sleepless nights, I'll be able to understand a fraction of what's being conveyed by these papers.
Oh, come on, guys! It's very easy to read those papers. Trust me.
That's what they told us about organic chemistry, and look how that turned out. All right, guys, take care.
Thanks, I really enjoyed this one.
Yep. All right. Good talking to you all. Goodbye. Take care.
Okay. See ya.
All right. See ya.